This is lesson 1-6, scatter plots. Scatter plots are used when you have to graph real data from real people and real life situations. And I think that what you'll notice in scatter plots, real people and real life data is not perfect. And everything doesn't conform to one straight line. Everything's not uniform. Everybody that is 6 foot tall doesn't necessarily wear size 10 shoe. It's different. Different people have a little bit different situations. So for scatter plots, what happens is you plot them and they're not in a line, and you try to decide if there's a relationship between the two different kinds of data. So instead of everything being in nice, neat little lines, you have to decide if there is a certain trend. So as we're looking at scatter plots, you will find that there are three different possibilities. There are positive relationships, negative relationships, and then no relationship at all. So as you're doing these, you need to think of starting a graph on the left and reading it from left to right, just like you would read a book. You always read a graph from left to right, just like you would read a book. And you look as x increases. So the corner here, x is always 0. And you think as whatever that is representing, as it starts at 0 and increases, what happens to the y? Well, if it in general increases 2, that's considered a positive relationship. It has a general trend uphill. If you have a general trend uphill from left to right, that would be a positive relationship. Just the opposite of that is if you start at the 0 and as x goes up, it starts out high and goes low. That is a negative relationship. It goes downhill. So you would write that as x increases, y decreases. Now, people sometimes confuse that. They think if it's a negative relationship, that means it's no relationship, but that's not true. Positive relationship and negative relationship, both of those, there is a relationship between the data. It's just one has a trend upward and one has a trend downward. Then there's always this situation right here, where you start out at 0 for the x, and as x increases, the data is all over the place. There's no relationship at all. You can't draw a general trend. So you know how you hear on TV or you read in a magazine how this study shows that these people, if they do this one particular thing, then they're more likely to do this. Okay, that's what we're talking about. It's a general trend, and it's not a set in stone situation. It doesn't mean that it has to be that way, but chances are it is that way. So I'm going to do a couple of situations, and we're going to have to decide if it's a positive relationship, negative relationship, or no relationship. So it's going to be similar to what you're doing in your homework. So let's write this in. Let's talk about the temperature outside. So you'll need to write this in. The temperature outside and your heat bill. The temperature outside and your heat bill. All right, so what I want you to do is the first part that they mentioned, that's always your x-axis. The first part's always the x, and the second part is always the y. So we're going to do this. We're going to draw an axis like this so that we can picture maybe what it's doing, and then have an answer, because you'll have to decide whether the temperature outside in your heat bill has a positive relationship, a negative relationship, or no relationship. Now, before we actually do this and I explain it, I want some of you to kind of come up with an idea in your head. The temperature outside and your heat bill. Anybody want to give their educated guess whether there's a positive relationship, negative relationship, or no relationship? Anybody want to just, go out on a limb and say, well, I think it's this? Anybody got an idea whether it'll be positive, negative, or none? The temperature outside in your heat bill. Callie, what do you think?
I think it's the Y is going to.
Do you think it's positive or negative or no?
I think it's positive.
Okay, so she thinks it's positive. Anybody else think it's positive? That there's a positive relationship? Anybody think it's a negative relationship? Okay, anybody think it's no relationship? All right, so let's do what we said. The first thing that's listed is the temperature outside. So that's going to be your x-axis, the temperature outside. And remember this corner, what's that corner start as right here? 0. So let's say 0 to, 100. So over on the y-axis then, it's going to be the heat bill, how much it's going to cost. All right, so we've got to start thinking about this from left to right. If the temperature outside were 0 or was 0, what do you think about your heat bill? If the temperature outside was 0, what do you think about your heat bill? It'd be high. It'd be up here. Okay, let's say that we go temperature 10 degrees. What's the heat bill going to be?
A little lower.
A little lower, but it's still cold. Okay, so a little lower. Let's say the temperature outside is 30 degrees. It's still cold. It's below freezing. But what about that heat bill? Is the furnace going to run all the time when it's 30 degrees? It's going to run a lot, but probably not as much as it did at 0. Okay, what about when it's 50 degrees outside? When it's 50 degrees outside, does some of your dads say, okay, we're turning the heat off, we're going to save money? Do your dads do that at 50 degrees? Good. 50 degrees, some people, they like 50 degree weather, and they're good with that. But you're still going to pay a little bit for your heat bill. But what if it was, let's say, 70 degrees outside? Are you going to even have a heat bill? Probably not. It's going to be like almost down here. And then definitely at 100, you're not going to have anything. So let's look at this. As temperature outside increases, the heat bill, what happens to the heat bill? Does it increase or decrease? Decreases. Okay, so what kind of relationship is that? Positive, negative, or none? Taylor? What? It's a negative relationship. A negative relationship. And that's where there's a relationship. Sometimes you get confused between positive and negative. And some people get confused and they think, oh yeah, there's a relationship, so it must be positive. No, that's not always true. Negative relationships exist too. It is a relationship, it just goes downhill. The Y goes downhill. The temperature outside in your heat bill. So that's definitely a negative relationship. Are there any questions about that? All right, I want to look at one more example, and this one is the minutes of study time and the math test score. So to kind of help us again, I'm going to draw a graph here to make us think about what's happening. And the bottom would be the minutes of study time. And remember, you start in the corner with 0 study time. And then the y-axis is your math test score. So the minutes of study time and your math test score. So remember, study time going from 0 to, I could say 100 or whatever. Okay, so minutes, how many minutes you study for a math test, and what would happen to your math test score. So does anybody want to take an educated guess on this one, what they think, if there's going to be a relationship, positive, negative, or none? Angela? Positive. How many people think there'll be a positive? All right, does anybody think there'll be a negative? And does anybody think there'll be none? All right, this is one of those situations where it's definitely scattered, because you know those people, and sometimes you kind of don't like them because they don't have to study at all and they're going to get an A on that test no matter what. There's people like that, right? Unfortunately. Maybe it's fortunate for them, but generally, as you're thinking about studying over time, it should be somebody that doesn't study at all. What should their math test score be? Low. And as they increase, 10 minutes, 20 minutes, 30 minutes, 40 minutes, 50 minutes, what should happen to their math test score? Yeah, overall, it should have a general trend upward. Now, is that going to be perfectly true for every person? No. There could be those poor kids that study for an hour and they still don't score a high math test score. You know, it's not a perfect science. There's nothing that says if you study for 30 minutes, you're going to get this grade. Or if you study for an hour, you're going to get this grade. There's nothing like that. So that's why there are scatter plots. It's not in a perfect line, kind of like I got here. It really would be somebody's here and somebody's here and somebody's here. But in general, if you go from 0 study time to a lot of study time, your math test score should go up. So the relationship between minutes of study time and math test score would be a positive relationship. And you would write, as study time increases, math test score increases. And that is how you would evaluate a scatter plot.